Hi, welcome to Algebra 2 Common Core. Today we're going to continue our discussion of exponents by looking at rational exponents. Remember that the word rational means that something, a number, can be written as a fraction. So we're going to be looking at exponents that are fractions. Now in the first box, you'll notice that we have a definition. This time we're going to look at what we call unit fraction exponents. Unit fraction exponents just means that our exponent is a fraction, but the numerator of that fraction is a 1. So you'll need to know this definition. B to the 1 over n is exactly equivalent to the nth root of b. So looking at some of our examples, we see that we have 25 to the 1/2. What this means is that 25 is the base, so that's our b value this time. The 2 in the denominator of the exponent tells us that we are doing the square root. And the 1 on top means that we're just raising it to the first power. So this would be rewritten as the square root of 25 to the first, which is just 25. Now, when we are taking a square root means that my root number is 2, but it's not necessary to put that root number inside of the square root symbol. Now we can take a further step and say that the equivalent expression, square root of 25, can also be evaluated as the number 5. We're not going to put a plus or minus 5 because when we're taking the square root, that means the principal square root, or the positive square root. For the next example, we've got 81 to the 1/2. This means the same thing when I have an exponent of 1/2. I'm going to take the square root of 81 to the first power. But the square root of 81 is just equal to 9, so simplified, this is just a 9. In exercise 1C, we've got 100 to the 1/2. So that means that we're going to take our base of 100, and a fractional exponent means that we're going to put it underneath, in this case, a square root, and then raise it to the first power, and the answer for this one is just 10. Now, sometimes our exponent will not be a 1/2. Again, we're still looking at unit fraction exponents where the top, the numerator of the exponent, is just a 1. So if I have 125 to the 1/3, the way that we would rewrite that as a root would be the cube root of 125. Now, because I'm looking for a number that can be multiplied by itself 3 times to get 125, I think about the factors of 125. 125 can be broken down into 5 times 25, and then 25 can be broken down into 5 times 5. So I see that the number 5 multiplied by itself 3 times gives us 125, so the cube root of 125 is just 5. 16 to the 1/4, well, that would be equivalent to the 4th root of 16 to the first power. I want a number that I can multiply by itself 4 times to get 16. That number is 2. 2 times 2 times 2 times 2 gives me 16. Now in exercise C, I see that there's a little bit different here because I have a negative 1/2 for my exponent. Recall from lesson number 1 that when we have a negative exponent, that means that we're going to rewrite this as 1 over 9 to the positive 1/2. So now I'm going to convert this over to a root. So 1 over the square root of 9. 1 over the square root of 9 is simply 1/3. So it was important to see that when we had a negative exponent, I had to take the reciprocal of the base. In part D, we also have a negative exponent, so I'm going to rewrite this as 1 over 32 to the positive 1/5. So that exponent gets changed to a positive 1/5 when I put the 32 in the denominator. This would just be equivalent to 1 over the 5th root of 32. But we know that the 5th root means multiply a number by itself 5 times to get 32. So that answer is going to be 1/2. So let's go on to see what happens when my exponent is a fraction that doesn't have a 1 in the numerator. So the rule that we have just been talking about is that when I've got a base raised to the 1 over n, that's just going to be equal to the nth root of b. And again, another way of saying that is the nth root of b to the first power. If, on the other hand, I have b to the m over n, where the exponent has a number other than 1 in the numerator, this is going to mean still the nth root of b, but it's going to be b to the m power. I could equivalently rewrite this as the nth root of b, all of that raised to the m power. So it doesn't matter whether I do the root first or I do the power first. Let's go on to exercise number 3 and rewrite as a root 16 to the 3/4. That just means that I've got 16 as my base, the root number is 4, and then the exponent is a 3. If at all possible, I try to do the root first because then that makes my base a smaller number to raise to a power and get bigger. So the 4th root of 16 would be 2. Then I'm going to raise that to the 3rd power. 2 to the 3rd power is equal to 8. For part B, 25 to the 3/2. Again, I see a fractional exponent, so that automatically tells me to make a root. 25 is the base. I'm taking the square root because the denominator is a 2, so it's not necessary to put a 2 there. Now, of course, you wouldn't be wrong to put a 2 as your root number. And then we will raise that answer to the 3rd power. The square root of 25 is 5. 5 to the 3rd power means 5 times 5 times 5, which is 125. In part C, we again have a negative exponent. So to eliminate the negative exponent, we're going to rewrite this as 1 over 8, making my exponent 2/3 positive. So now this is going to be equivalent to 1 over, the root number is 3, so the cube root of 8 to the 2nd power. Now again, if you think about this, I can do the cube root first, so that gives me 1 over 2 to the 2nd, which is 1/4. Alternatively, I could have done the 8 squared first, and that would give me 64, and then I could take the cube root, and the cube root of 64 is 4. So regardless of whether I do the root first or the exponent first, I'm still going to get the answer of 1/4. Take a minute to write these you try it examples in the box in your note packet, and then pause the video and try the problems and come back and check your answers with mine. Please check your solutions with my answers. If you have any questions, please come and see me about this. I know some of you are probably wondering if we could have done these on our graphing calculator. And the answer is yes, it is possible to calculate numbers that are raised to exponents on our calculator. However, I'd really like you to try these without your calculator so that you get a better feel for what these exponents mean. In the next examples, we're going to switch over and have our bases be variables instead of numbers. So in exercise number 4, you're asked to again rewrite an exponential as a root. And you'll see that this time the bases are variables, and again our exponents are fractions. So if I see x to the 2/3, I'm going to rewrite this as x, the root is 3, and the power is 2. Now again, I could equivalently rewrite this as the cube root of x squared. So both of those are equivalent root expressions for x to the 2/3. A to the 5/2 means that my base is going to be a. My root number is a 2, which you can either put in or leave off when it's a 2. And then I'm going to raise to the 5th power. Now if you think back to Algebra 1, hopefully you remember simplifying square roots, where I have a to the 5th, meaning that I've got 5 factors of a underneath the radical sign. Every time I have 2 matching factors underneath a square root sign, that means that I've got a perfect square and I can take it out of the radical. So one of the a's comes out, the other pair of a's come out, and when I rewrite this, this would be a squared times the square root of a. Every time I take the square root of a squared, it's just giving me an a out in front. And I've done that twice, so that's why I have an a squared as the multiplier in front of the square root of a. In part C, I see that I have a negative exponent. So the first step, always for a negative exponent is to rewrite as the reciprocal. So 1 over y to the 3/4. You'll notice that we don't take the reciprocal of the exponent, we take the reciprocal of the base. We put the base underneath 1 to make the exponent positive. So equivalently, as a root expression, this would be 1 over. The root number, the bottom number of the exponent in the denominator, is a 4. So this would be the 4th root of y to the 3rd. And again, the 3rd can either go outside the root sign or with the y underneath the root sign. To finish up with exercise 4D, we're going to say x to the 4/7 means that my base is x, my root number is 7, and the power on the x would be a 4. Now in both of these last two cases, you'll notice that the root number was a bigger number than the exponent was. So that's why we couldn't go any further to simplify like we could on example B. On example B, we saw that the exponent was bigger than the root number, so that told me that I could actually simplify that root. Now please write down the you try it's in the box in your notes. Then pause the video and come back and check after you've tried these on your own to see if you can simplify just like we did in exercise 4. Please check your solutions with what I got for my answers. And again, if you have any questions, please come and see me. You'll notice that in part C, we were able to simplify the square root of x cubed by thinking of x cubed as the product of x times x times x. So a pair of x's multiplies together to give me x squared, and the square root of x squared is x. So that's why we have an x out in front of the radical. In exercise 5, we want to simplify using our rules of exponents, showing that the rules of exponents that we learned in the last lesson apply even when I have fractional exponents. So in exercise 5a, I see that I'm raising a power to another power. So if you think back to that rule, when I'm raising a power to a power, I'm going to multiply the exponents together. So 1/3 times 6 gives me a to the 2nd power. In part B, when I am multiplying two exponentials together and the bases match, in this case both bases are x, then think back to our rule. That means that we're going to add our exponents together. So we're going to have x to the 2/3, and we're going to add the exponents together, so 2/3 plus 5/3. So this gives us x to the 7/3. Now, this one did not tell us to rewrite using a root, so I can leave my answer as x to the 7/3. In part C, I see that I have division between two exponentials that have the same base. So when I have division, that tells me keep my base of y and subtract the exponents. So that means that I'm going to have 3/4 minus 1/2. That's going to require a common denominator to subtract. So that's going to be y to the 3/4 minus 2/4, or equivalently y to the 1/4. For the last part, I've got b to the -2 raised to the 1/4. I'm going to first of all use my rules of exponents to say when I'm raising a power to another power, I'm going to multiply my exponents together. So that gives me b to the -2/4. But -2/4 is the same as -1/2. Now I never want to leave a negative exponent in my answer, so I'm going to rewrite this as 1 over b to the 1/2. So I made that exponent positive by moving the b to the denominator, and that changes the exponent to positive 1/2 instead of negative. Keep reviewing your rules of exponents and try to get a good feel for what happens when we have a fractional exponent. We'll practice some more of this in class the next time.